2007 Ford F-350 Super Duty with the 5.4 engine. Yes, they put a 5.4 in an F-350 Super Duty. So issue is the vehicle will not start. So if you were to put it in park, it won't start. So we're going to hook up. We got the scan tool hooked up, key on engine off, did a full system scan, and we'll go from there. All right, so we got the scan tool hooked up, did a full system scan, and heater oxygen sensor code don't care about, evap don't care about. What we do care about is the Prindle switch, circuit range performance 706 code, transmission range sensor circuit low input, which means it's probably not getting voltage, P1000 because it hasn't done all of its tests yet, and then P1702 transmission range circuit. So if the transmission range circuit is not reading correctly, it will not let the computer control the ground for the starter. So we're going to go back and go to live data. Let me pull up the schematics here. I have them printed off. So pull up live data. While that's doing that, so your starter relay, the relay power comes in to the central junction block. All this wiring is good. We checked all that. The computer controls the ground. The computer controls the ground, and it'll start it. You can jump pin 87, which we did, key on, and it'll start. But the computer is not controlling the ground. It is, but it won't, because if it's not in park or neutral, which we're going to show you on the live data once it pulls up. All right, so we got live data pulled up. So transmission range says error. It should say park because it's in park. And you should have a transmission range percentage, which is duty cycle, time versus on, time versus off square wave, and transmission range in hertz. For example, a certain hertz, maybe 50 hertz, is maybe park, 30 hertz is neutral, and so forth. That's not the actual specifications, but that's how this thing reads along with duty cycle. So right now this isn't reading, so the vehicle does not know if it's in park or neutral. But what we do now is, if you look at the schematic for it, the transmission range sensor, circuit A, comes down from here and it gets power from the vehicle reference. It's either 12 volt or 5 volt reference from the PCM. And then you got your ground to your ECM, and then your sensor wire feedback frequency duty cycle going to the ECM to tell it what, gear, park, reverse, neutral, drive it's in. So we got to get to this connector, which is connector C1385. Is it the wiring, or is it the sensor itself? Sensor is inside the transmission. And it tells you in here, the sensor contains electronic circuitry that provides a PCM fixed frequency at a duty cycle for each of the various positions of the manual lever, park, reverse, neutral. The PCM uses the sensor signal for engine functions, start, reversing lamps, and for pressure control, shift scheduling, and TCC operation. This thing does not shift right. It's stuck in second or third gear because of this. It's a duty cycle, pulse width modulated frequencies type of sensor. So we want to get to this connector 1385, check power to it, check ground, check the frequency. We can use a function generator, so I can send a frequency back, see if we can read it on the scan tool. If we do, we know the wire integrity is good, and then the sensor's bad. You just got to pull the pan and get the sensor. But we got to get to this connector first. And then obviously this will all come back and read correctly once the problem is fixed. All right, so we got to get to the connector, which is connector C1385, to get to these pins. And if you look under the vehicle here, okay? Get shit in your eyes. The connector is right there. So we're going to clean that up before we pull it apart. Take the 10 mil, start shooting wires. All right, so we want pin, for the power side, we want pin 21, circuit 371 pink with a white, pin 21, It's 371, pink with a white reference voltage. And that circuit A comes from right there, comes from the PCM vehicle reference. So what I got over here, got my power probe hooked up, 2 battery, and I got my connector off, and I got my AS wave kits in there, pins and pin 21. What I'm going to do now is go on the ground. My assistant, when I tell him, is going to turn key on, engine off. Go ahead. So we got 11.7 volts. So that means the power wire is good. What we're going to do now is check the ground wire and then the signal wire going back. All right, so now we're going to check the ground. Pin 17, gasoline engine, orange, 1867, goes to the PCM. So it's always going to have a ground. There's pin 17, circuit 1867, orange, transmission, range sensor assembly, ground. And I already got it hooked up underneath there on pin 17. And I got a good ground, 0.0 volts. Now if I had 100 or 200 millivolts or more, I would have definitely a ground issue. But I got 0.0 volts, which tells me my ground is good. So what we want to do now is check the signal wire. There's 2 ways we can do that. We can disconnect, which I already have it disconnected from the training computer. We can disconnect the engine computer, check continuity, check shorts, all that stuff. But what we can do is use a function generator as well and send the signal down through the computer and read it that way. All right, so now what we're going to do is we're going to check the signal wire here. We're going to put a frequency through it and check continuity. So we want to set up our scope. And if you look in the tech data, it says, is the frequency between 100 and 150 hertz. We're going to set it in the middle, 125. And then park is minimum duty cycle 7 to 27 minimum, 23, 24% max. Reverse is this. So we're going to set it to park. We're going to go to 7. We're going to go to, like, we'll split the difference. We'll just call it 12% duty cycle and 125 hertz. So I got my Maxis Ultra hooked up with the VCMI, has a function generator built into it. And I'm going to set up 125 hertz. Sorry about the glare. And then duty cycle, I said we're going to go, I can't remember, we'll go 15%. We want a square wave. We want 12 volts peak to peak because 12 volts was coming in. We're going to hit play. And then we have another scope hooked up to it, checking the leads just to make sure. So there's your square wave, 125 hertz, 15% duty cycle. Now, if you change your duty cycle, changes the on versus the off time. And if you change your hertz, you change your frequency. Should have to look there. And you can change your peak to peak voltage. This is good for testing wheel speed sensors and stuff too. All right, so now what we're going to do is, like I said, the signal wire. We're going to actually ground this one and send a signal through here. Hook these leads up, which I have the function generator, like I said, hooked up. And then we got that data showing air right now. So we're going to hit play. So we got a square wave, 12 volts, peak to peak, 125 hertz, 15% duty cycle. And if you look, both scan tools here. So if I stop it, air's out. It airs out. And if I hit play, it says it's in 1. Transmission percentage, 85% duty cycle, which is, we got to change that because we're doing a different duty cycle on there. oh, it's 85 and 15 adds up to 100%. So we're reverse counter duty cycles, that's why. And if transmission range is 125 hertz. So now, if I change this frequency, I'm going up here, 22 and 78 is 100. If I go up here, it'll lower the frequency on here. We're in second gear. We're in third, or overdrive there. There's neutral. Let's go to park. Reverse. You gotta be under 23, I think it said. I can't remember what it said. Park's right there. Yeah, we're good. So 12% duty cycle, like on the data we showed earlier, which we're going to pull back up. 12 and 88 adds up to 100% duty cycle. So we're in park. So we're going to go ahead and see if it'll start now. Of course, it's not going to shift. We're just going to see if it'll start. But that proves our wire integrity to the PCM is good. We'll go ahead and crank it over. And it starts up because it thinks it's in park. I mean, it really is in park because I put it in park. I'm going to go ahead and shut it off. Leave key on engine off. Of course, we're going to have some anomalies on the scan tool. It'll air out. Sometimes it'll come back only because we are sending a signal into the PCM with this. But we can go to, I don't know, let's go to 25% duty cycle. I can't remember what the chart says. I just want to, it says it's in second gear. We'll try to start it real quick. It should not start. He's going to try to crank it, but it should not start. Nothing. Okay, leave it. We're going to make it go into neutral. Which neutral is, let me look it up again quick. All right, so to get to neutral, we're going to go 38 to 48%. We're going to go to 40. So we want 40 on here, so which would mean 60 on here to add up to our 100. I'm going to change this to 100, or not 100, 60% duty cycle, 125 hertz. Boom, neutral. 60% duty cycle plus 40 is 125 hertz, or 100. So now it says neutral. So go ahead and start it again. It should start now. We just proved park. Now let's prove neutral. Hang on a sec. I had to come back and adjust my duty cycle to 55% and 45 there. Now it's, we were just on the edge, I believe. There's neutral. Go ahead and start it. There we go, leave it running. All right, a couple more tests here. So what we did, I'm not going to show it on film, but we checked wire continuity from this connector on the tranny to the engine computer. This connector wire on the tranny to the engine computer connector. We checked for continuity, we're good. We checked the short to voltages, nothing, and short to grounds, nothing. So all that stuff checks all good. And now, using the pinout on the engine computer. But now what we want to do, what we have unhooked, the computer's all hooked up. Got our VCMI up there. And then we got a lead going down to pin 15, which is the signal wire. This is the ground. This is the signal wire. I might have misspoke earlier in this video. This is the ground. This is the signal wire when we had it hooked up. So pin 15 hooked up to signal. And then the other end of the lead from the VCMI function generator to ground. And key on engine off. We got a square wave, 12 volts peak to peak DC, 125 hertz, 45% duty cycle, and it's in neutral. And if I can increase this, overdrive and so forth. So we're going to go back down. We're going to make sure it starts. The transmission connector's unplugged. I'm going to start it just to show that. Make sure all of our wires are clear, which they are. I want to start it and turn it right back off. Let me get over here quick. Alrighty, so I had to change the frequency to 135. This gives you a rough idea what it's at. Or the frequency gives you 100 to 150, so we have to be at 135. So now we're neutral, now it'll crank. Well, battery's a little weak, but you can hear it cranking there. We had the key on engine off for a while, but it does crank over now. So, just like we proved earlier, yeah, we're down low voltage, down to 10.7 volts. So what I want to do now is we're going to hook back up the connector on the transmission, and I'll show you our anomalies with that. But before we do that, we're back to neutral. Like I said, they changed our frequency a little bit to get it, because it says 100, 150 in the tech data, but you got to kind of be, well, you got to be within the range, obviously, which we are, but it doesn't give us an exact hertz. So we're within there now. That's why it would start. So like I said, we're going to go ahead and hook up the transmission connector now. Actually, before we hook it back up, transmission connector under the vehicle unhooked, PCM hooked up, the signal wire going in, which is, let's see where my hand is, that pin right there, right on the computer right there. We're sending a signal in, key on engine off, and if you look, we're in neutral frequency, everything's reading. But I'm going to have my counterpart hook up the connector, and we're going to watch while he does that. Actually, I'm going to turn the key off before we do that, but all this stuff will go away because the sensor inside the transmission, the transmission range sensor in here is internally shorted and it's taken the whole circuit down. All right, so function generator's hooked back up again. Key on engine off. We hook the connector back up under the truck to the transmission. All connectors are hooked up. Key on engine off. Send a frequency. Same thing, 135 hertz, 43% duty cycle, and we got an error. But the reason we got an error is because it is internally shorted. So while he's under there, I'm going to have him pull it off while we watch this. So I'll go ahead and pull it off.
What?
The connector, the one you just put on.
It's just tight. It's ready to go.
All right, so he's going to pull it off while we watch this. We got the function generator on. It's airing out because it's internally shorted in that digital sensor. Let me know when you're pulling out.
We're bolts out, now we're pulling out. Okay.
Pulled out, boom. Everything reads again. And he did that with the connector on their transmission. Why is that doing that? Like I said, it's the transmission range sensor inside this digital sensor is shorting the whole circuit down. We just proved all the wire integrity, power, ground, signal, with the freak generator, all that stuff worked out well. It's absolutely that transmission range sensor that is bad on this truck. So the panels needs to come off and remove and replace that transmission range sensor. And that is it for the 2007 Ford F-350 with the 5.4. Alrighty, so I know I said I was done with this video, but I had to sleep on it a little bit longer. It's not the Prindle switch. In this case, I slept last night, I was thinking about it, and I was looking at it, I'm looking at the diagrams, and we're getting no continuity on a ground wire when we should have continuity. We're getting continuity on another wire where we shouldn't have continuity. So we're going to pull up schematics. I'm going to show you what I believe we got going on here. All right, so after doing some more research and looking at it, again, this Prindle switch is not internally shorted. It is good. And the reason why, this power wire is good. No short to ground, no short to voltage. This wire here, the signal wire, is good. No short to ground, no short to voltage, continuity is good. This wire, from this pin to this pin, we have no continuity, and I'll show that. Originally thought maybe there's something wrong with the schematic. No, the schematic's not lying. So pin 17 on connector 1385 at the transmission, and then pin 50 on Charlie 175 Charlie, connector 175 Charlie, pin 50 on the engine computer. 17 on the tranny, 50 on the engine computer. Orange wire, that's your ground signal. Should have continuity through it, which we don't. So if you don't have ground to this is like a little module. It'll never turn on. Even though we used a function generator, we bypassed all this. That's why we could do all that. We bypassed this whole thing. So we're going to check from here to here, which pin 50 is the end there with my thumb, which is the orange wire at the very end right there. And then under the vehicle, I'm going to go under there and show that. So under here, pin 17 is the ground. I just got to find it again. Which is, sorry, I'm trying to film this at the same time. Right there. It's in the very corner. There's pin 17. Flip it around. That's the orange wire right there. That's the ground. We're going to check from here to the computer. We are supposed to have continuity, which we don't, which I'll show you right now. All right, so now I'm in pin 50 up here, which is the orange wire. Pin 17 down here, which is the orange wire, which should have a continuity. There's no connectors in between. There should be continuity between there. I'm on the highest scale, 20 million ohms, and I have nothing. I should have continuity, and I got nothing for continuity. And since we're here, we'll check it short to ground, just in case. Always on the high scale when you're checking short to grounds, nothing. So I have no continuity on that wire. However, if I go to pin 49, right next to it, I got continuity, which is completely wrong. 0.3 ohms. That's a yellow with a white tracer, the second one over. Well, pin 49, yellow with a white tracer, I'm gonna have to look that up here. That's a power wire, and I'll show you that next. So we're gonna pull up 175 Charlie, which is the connector there up to ECM. So there's two schematics, but we want to go to, I'll show you the first one, which is the engine computer there. Yep, but we want to go to pin 49. So second page. So 50, the first one, like I said, is the ground circuit 1867, transmission range sensor ground. We don't have continuity. But we have continuity to pin 49, shift solenoid vehicle power. That yellow and white wire, which is right there, we have continuity, yellow and white wire to ground. That's a power wire. That's sending 12 volts, and it splices off to, I think it's pin 20, 24, and 7 down there, and it splices off to power up the shift solenoids. Well, this should not be power on a ground wire. So what's happening is we're getting power on a ground wire, which I'll show you that next. All right, so I plugged my connector back in. Don't worry about this wire that I cut right there, the yellow and orange, or the yellow and white tracer, because we had to cut that to prove this is the problem. So that's still connected. We'll fix that later. So this is plugged back in. The connector unplugged under the vehicle's unhooked. We're still probed in pin 17, which is the ground for the transmission range sensor. going to my meter, going to battery ground. Now we're going to get a negative number on here because I got my leads reversed. We don't care about that. So when I turn key and engine off, we're checking the ground on the bottom of the vehicle. You should have 0 volts. But we don't, we get battery voltage. So I turn key on engine off, because it ain't gonna start. We got battery voltage. Again, it's negative just because my leads are reversed, so don't worry about that. We got battery voltage on the ground wire coming from the computer. Because this yellow wire with this white tracer is the power wire to power up the solenoids in there. That's shorted to the orange wire, but the orange wire has no continuity because it's open. So it seems like the orange wire is open. It is open because I have no continuity. The yellow with the white tracer is shorted to the orange wire down under the vehicle, and that's why we're getting power on the ground and why the module won't turn on. So now I'll show you what we're going to do next. Alrighty, so the connector under the tranny's plugged back in, engine computer is plugged back in, and if you watch, we're gonna have a no crank, no start, nothing. So what I'm gonna do now is I'm going to unhook this wire, this orange wire that I cut, which we'll fix later like I said. I'm going to unhook that. I could have depinned it, but we're probably going to have to run a new wire anyways, or definitely find we're shorted. So what did I do? I unhooked this wire. Now there's no power going to the ground. It's not a short to ground. We took that out of the equation. Now it's not going to power up the solenoids in there obviously. Now what I'm going to do is underneath the vehicle on pin 17, which is the ground, I have a jumper lead. I can't even get my camera in here. But I got it. It's so hard to get it up in there, but I have a T-pin back probe in the pin 17, the orange wire. And I'm taking the other end of the wire, because that's it, that orange wire is open. Taking the other end, and I'm going to T-pin the back of the orange wire here, how it's supposed to be. So now what I have is the orange wire is connected like it's supposed to be from the factory, even though it's not because there's open on the circuit somewhere. And this orange wire is disconnected because it was short and that went off, so we don't take power off it, so we don't have power short in the ground. Now we're going to try to start it. Alright, before we started, just to review. The orange wire is an open circuit. I'm taking the pin 50 on here, down the pin 17 on the connector, and using a black lead or just a wire to make that connection because it's an open circuit. The orange, yellow with an orange I cut for now, we'll fix it later, but I cut that because we're going to have to rerun it or find the actual problem, because that yellow with an orange, yellow with a white tracer is shorting to the ground wire. That's why it'll never work to power up that module. So I disconnected that. So now, and everything's hooked up. No function generator, nothing. It should start right up now. Starts right up. Now we're gonna have engine light on, tow haul flashing because we don't have our solenoids hooked up, because we unhooked that power wire that shorted the ground. So I'll turn it off, I'll do it again. I'll do it one more time. And then what I'm gonna do now is I'm gonna hook up the scan tool to look at the duty cycle, the frequency, and the Prindle switch. All right, so I got the scan tool hooked up. So we're in park. 14% duty cycle, the frequency is good. I'm gonna go ahead and start it again. It runs fine. All right, so we're in park, key on engine off. I'm gonna move it through the gears here. There's reverse, there's neutral, there's drive or overdrive. 3, 2, 1. See, the frequency is all about the same. Back to park. Start it again. It's good. Now we're going to try it in neutral. Good. Now we're going to try it in drive. Better not start. Nothing. Reversed. Reverse, nothing. Back to park. Every time. So, what we're going to have to do now is one of two things. A, find out where the orange, well, this whole harness runs down by this exhaust valve, or the valve cover, the head, and the exhaust manifold, and then goes over the tranny to the back, to the side of the transmission. Then you got to look for the orange wire that's broken, and the yellow with the white tracer that's shortened to the orange wire down there farther. Got to find that. You can fix that. You can fix it that way, or since it's an older farm truck, we'll have to talk to the individual and see if they want to just run a new wire from the orange one down to the other one, orange one down there, and also run a new wire from the yellow with the white tracer down to the connector, but down to a splice point, because that yellow wire with a white tracer splices off to 3 different places. So you'd have to get down to a splice point and splice it down there, so you can make sure you're past the short and run the new wire. So that's the 2 ways you could do it. First way, it's kind of hard to get to everything because it's on top of the tranny. I mean, we look at the most suspect area would be on the manifold or down by the transmission. Look at that. But if not, if you want to run a new wire, you could run a new wire, orange to orange, yellow with a white tracer down there to the splice point to get rid of that short, and then this thing would be fine. But that's 100% what the problem is. The Prendo switch is good. When we did earlier in this video, we did a function generator. That was a separate circuit because we're using the ground separately, and I was using a ground on the battery. That's why it red, so we proved that other wire was good. But it's kind of interesting that the orange wire is open and the yellow with the white tracer is shorted to the orange wire down there somewhere. So that is it for this video for this 2007 Ford F-350. Actually, one more thing. So when they splice the wire in, if that's what we end up doing, the orange one, you're gonna have to cut down here somewhere, cut off, run a new wire, go down the pin 17 on the connector down there, run a new wire, and then this one's already cut, splice off of this, and go down, and then let's get under the truck. I'll show you under here. So get under there. Alright, so it's kind of dark under here, but the other one you're going to have to splice off pin 17 for the ground, which is the orange wire, which is that one, to pin 50 on the computer, and then pin 49 for the yellow and orange is this one, but the splice is 3. There's 1 up here that go into 3 down here. So if you go up past that splice point, splice in there, and run the other wire. So yellow and orange, 3 wires come down to here. But go past that point, go up to, from this splice point up to pin 49 on the connector on the computer. It's not focusing here. And then down here, pin 17 for the orange wire to the ground, to pin 50 up on the computer. And then that'll fix this issue with this truck. Because we took these wires apart, opened them up. They were like together pretty well. I mean, there's tape on them. They got heat on them. They're up there farther. So I mean, you could open the harness up more and try to find the problem, or you could just run with new wires. But it's been in there since 2007 like this. Or you can see some marks on the wires and stuff. Some insulation removed from sitting there as well, or from all the heat and stuff. So you can find the problem up there in the harness, or run 2 new wires, and that is it. All right. Just wanted to add something to the end of this video.
Sorry, I'm kind of losing my voice. I have a bad head cold. But both the Prendo switch and the wiring's bad. But we end up fixing the wiring. We ran a new ground wire from the engine computer connector to the transmission connector, which is the orange one. And then we ran a new wire, power wire, from the engine computer down to the splice point at the transmission connector. So now it starts up. It'll start up fine. But after a little, if you try to shut it off and then start it up right away again, it won't start up because the Prendo switch module inside the transmission, I believe, is overheating. So you got to reset it. You got to turn the key off, let the computer shut off, and then restart it. So wiring's fixed. It had bad wiring and it has a bad Prendo switch. It's not your normal analog switch, it's a digital switch used based on frequency, and duty cycle tells the vehicle, you know, what gear it is in and when to shift and so forth. So when that power wire shorted to ground, which is the ground on the Prendo switch inside the transmission, I took that Prendo switch out. So the wiring's fixed. There you go. Now the individual will replace the Prendo switch inside the transmission, and that'll be good. So that is it for this video.